Okay, so again welcome to my channel. So last video we have discussed about differentiability or derivative of modulus function, that is a part of differential calculus. Today's class also we try to discuss something related to differential calculus. So what topic we will discuss? Let's start and then you can guess. Friends, carefully look into the board. There are 4 diagrams. Look into the curve, look into the nature of the curve. In the first curve, the curve is going up. The second curve, the curve is going down. The third curve, the curve is going up, then flatten for some period, then again it will go up. In the fourth curve, the curve is going down. After some time it is constant, then again going down and going down. So, seeing this curve, you may understand what topic we can discuss today. Yes, you are right. The topic is increasing and decreasing function. We will be discussing. Okay. So, before deciding this topic, I was a bit confused that what I should discuss about increasing and decreasing function, because there are very good books in the market which will give you enormous number of problems for increasing and decreasing function, which you can follow and you can get the idea that what is increasing function, how you can check whether some function is increasing or not, and how you can do the problems. And mostly in all YouTube videos I have seen the same logic, the things. So I think I should do something different. So what I should do, I should try to analyze the theory behind increasing and decreasing function. Okay. So what is the meaning? So let's start and you can then understand. In the last class, if you follow the last class, if you not, then the link is given in the description section, you can go and follow that. Last class we have given the derivative definition. What is the definition? Say f dash a equals to limit x tends to a fx minus fa divided by x minus a. So this is the derivative definition of a function f at a point a. Okay, that we have discussed in the previous class. Now here I want to say something. See, look into this part. Limit x tends to a. What does that mean? That means if you draw the number line minus infinity to infinity, there is some point a. Now x is tending to a. Now x may tend from the left hand side or x may tend from the right hand side. So if x tending to a minus, minus means from the left hand side of a, that is x is somehow here, then it is going towards a, then the value of x will be less than the value of a. So x minus a will be negative because the a value is maximum and x value is minimum, so it should be negative. If x tending to a plus, that is x is approaching a from the right hand side, that is the more value from a, then x minus a will be positive. So friend, I want to mention that these two things you should understand, that x minus a is negative and x minus a is positive when. Okay. Now if I say f dash a greater than 0, what does that mean? That means limit x tends to a fx minus fa by x minus a greater than 0. That is because f dash a is this one. That means this quantity will be positive. Now when this quantity will be positive? When both will be of same sign. So this fx minus fa positive and x minus a positive, or fx minus fa negative and x minus a negative. So what we have done, we have taken f dash a and we have given a condition. Let's see what will happen when f dash a is positive. So when f dash a will be greater than 0, then the ratio has to be greater than 0. So the ratio will be positive only when the numerator and the denominator will have the same sign. Either both should be positive or both should be negative. That we have discussed here. So this will be positive if the numerator is positive, denominator is positive, or the numerator is negative, denominator is negative. What does that mean? That means fx less than f of a when x less than a. Okay, now you see what does that mean. If this is a point, so I am writing this condition on the graph. I try to plot. So fa, so this is a, this is fa. Okay, now what it is given, when x less than a. So when x is in the left hand side of a, then fx, the value will be less than f of a. So fx may be something like this. Understand? Then by the same logic, in the second condition is fx greater than f of a when x greater than a. So this is the first condition, and now I am drawing the second condition, that is when x is more than a, that is the right hand side of a, then fx value will be more than f of a. So when I cross a, then fx will be more than this value. So that may be, so this one. Understand? Now you see from the diagram, so what we have got actually, when f dash a greater than 0, that is at this point when derivative is positive, then the function is going upward. That means the function is increasing. So increasing when f dash a is positive. Okay, and it is increasing at a, at the point a. Now by the same logic, if I write if f dash a less than 0, then what will happen? Then fx minus fa divided by x minus a will be less than 0. So that is when the derivative is negative, then the ratio has to be negative. So when the ratio will be negative, when numerator and denominator will have different sign, that is the numerator will be plus, this will be minus, then it will be negative, or the numerator will be minus, this will be plus, then it will be negative. So fx minus fa less than 0 but x minus a greater than 0, this is one situation, or fx minus fa greater than 0 but x minus a less than 0, that may be one of the situation. That is the both sign has to be different. So what does that mean? That means, so fx will be less than f of a when x less than a, x greater than a. What does that mean? Now again, if I draw the thing, so this is a point, this is say f of a. When x greater than a, that is when x is in the right hand side of a, then fx will be less than f of a. So when you cross a, then fx value will be less than f of a. So f of a will be more than all fx. And in the second condition, what we have got? Fx greater than f of a when x less than a. So the second condition we have got, when x is less than a, then fx will be more than f of a. So it will be something like this. So now you see from the diagram it is clear that the curve is decreasing. Understand? So we have getting two conditions, that when the derivative value will be positive, then the curve will be increasing. When the derivative value will be negative, then the curve will be decreasing. Now the common question is coming in the mind, that what will happen if the derivative is 0? So we have considered derivative is positive, derivative is negative. So what will happen if the derivative is 0? So if f dash a equals to 0, that means the ratio will be 0, that means fx will be f of a and the function will be constant. Okay, so we have got three conditions, or you can say three features of a function to be increasing, decreasing or constant. If the derivative value is positive, then the function is increasing. If the derivative value is negative, then the function is decreasing. If the derivative value is 0, then the function will be constant. So I think that is okay for the theoretical part. Now let me give one problem. Let us start. Say say I have given fx equals to say x square minus 3x plus 1. So this problem is given to us and we have to check that the function is increasing, decreasing, or what is the nature of the function. So what is the nature of the function? That we have to check. So what will be the first job? See carefully. If you look into the theory part, we have considered f dash x equals to 0, greater than 0, less than 0. So first of all, you have to find f dash x. So what is f dash x? 2x minus 3. Now what is the next thing you have to do? F dash x equals to 0. So that will give you x equals to 3 by 2. So now we have got this number line and we have got the point 3 by 2. Okay. So you can understand that f dash x is 0 when x equals to 3 by 2. So the function is constant when x equals to 3 by 2. That we know. Now we have to check the left hand side of a and the right hand side of a. Okay. How to check that? So when x less than 3 by 2, then f dash x equals to 2x minus 3. Now x is less than 3 by 2. So how you can check the value of f dash x? It is negative or positive. What is the common thing? You take any value in the left hand side of 3 by 2. Say x equals to 0. Say f dash x at x equals to 0, it is negative. So in this portion the function is decreasing. Again, when x greater than 3 by 2, that is if you are more than 3 by 2, then f dash x equals to 2x minus 3. So you take any number more than 3 by 2. So say x equals to 2. So then f dash x at the point 2 will be 1. It is positive. So understand? So what is the nature of the function? The function, that means from minus infinity to 3 by 2. So if I just write from f is decreasing on the whole left portion of 3 by 2. So minus infinity to 3 by 2. Open interval. What is the meaning of open interval? That means we are not considering the end points. We are considering all the points in between the endpoints. So we are not considering 3 by 2 because 3 by 2 the value is 0. So anyway we will not consider, and f is increasing on 3 by 2 infinity, positive infinity. So that means what we have done that one function is given to us. First of all, we take the derivative of the function and we check that at which point the function derivative is 0. We have got a point 3 by 2 for this problem. Next, we consider the left hand side of 3 by 2. We have seen the nature of the function is decreasing. We have considered the right hand side of 3 by 2. So the nature of the function is increasing. So that is the final conclusion, that minus infinity up to 3 by 2 the function is decreasing, and 3 by 2 up to infinity open interval the function is increasing, and at 3 by 2 the function is constant, that is the derivative is 0. So that's all for this class. So what we have discussed in today's class, we have discussed a very simple concept of increasing and decreasing function, and basically instead of doing problems we derive the condition that why the derivative is positive then the function is increasing, why the derivative is negative then the function is decreasing. We try to derive that, and finally we done a simple problem. So what is my suggestion? You please do some problem and try to follow the process, and back of the mind the theory should be there. Then only you can successfully do all the problems. Thank you for watching, and one more thing, please subscribe the channel. That will encourage me to put new videos. And please give any suggestion, whether it is positive, negative, and feel free to answer all the questions. Thank you.